Hello everyone, today I want to tell you how the electromagnetic catapult of the project ship will be far superior to the steam catapult. In addition, President Xi Jinping pressed the ejection button and the Fujian Southern aircraft carrier entered the queue. And Trump is jealous of China. Why do they think their aircraft carrier can eject 5th-generation aircraft? The Fujian aircraft carrier held a flag-selling ceremony in Sanya, Hainan on November 5. President Xi Jinping, chairman of the General Affairs Commission, attended the ceremony. CCTV news broadcast exposed the details of President Xi's inspection, including his praise of carrier-based aircraft pilots who also have such extraordinary courage for test flights. You are all heroes. President Xi entered the cockpit again and set sail for 100 days. Zhang Son's signature was private, but the empty hole in the fighter's case plywood was removed, as if an arrow had left the part. The attachment ship is China's first electromagnetic catapult. In the past, China's two aircraft carriers were aircraft carriers with traditional or weak takeoff ships in fighter jets. Although the Fujian ship is a conventionally powered aircraft carrier rather than a nuclear-powered aircraft carrier, its electromagnetic catapult system is more advanced than the electromagnetic catapult of the U.S. aircraft carrier and more reliable than the U.S. system. Can eject 55 of these 5th-generation fighter jets, making China the first country in the world to launch battery-launched 5th-generation aircraft. The U.S. aircraft carrier footed did not catapult the F-35, these 5th-generation fighters. The poor performance of the U.S. carrier made President Trump very dissatisfied. He saw that China's Fujian carrier had completed electromagnetic catapult takeoff and navigation training of the 5th-generation F-35 for the first time during the sea trial on September 12. China and the U.S. have achieved a milestone in carrier technology. Trump is naturally unhappy. During his visit to Japan, he gave a speech on the USS George Washington at Yokosuka Naval Base on December 10. He was dissatisfied with the U.S. aircraft carrier's electromagnetic ejection system, saying the battery ejection system was costly and hard to use. He also stated that the general has stopped all electromagnetic ejection projects and will return to steam ejection. In his speech, Trump mentioned that he continued to sign an executive order requiring future aircraft carriers to use steam-powered catapult systems in hydraulic lifts. This is not the first time he has criticized the electromagnetic catapult system. During his first term, he once said that this system is too complex and costly. It should be a digital system, which costs hundreds of millions of dollars more and is not practical. Trump's disappointment with the battery bomb system mainly stems from the performance of the Ford aircraft carrier. 17 years after the aircraft carrier was launched, due to frequent technical problems with the electromagnetic catapult arresting device, the time for the formation of combat effectiveness was postponed until 2023 for the first combat deployment, at least 5 years later than the original plan, even though the U.S. Navy declared that the Voto was combat capable. However, in terms of stable and sustained operations, there are still many problems. Even everyone is afraid to eject the F-35C 5th-generation fighter jet, so basically only the F/A-18 Super Grand Hungry, a 4th-generation fighter jet, is deployed. Military expert Zhang Junji said that the battery ejection failure rate of Ford River is relatively high. The design requires it to eject without failure 4,166 times. However, in actual tests, a failure will occur on average every 200 times, and the repair time often takes 1 to 3 days. Also, the Ford has not ejected an F-35C stealth fighter yet, which affects its combat effectiveness. However, analysts believe the chance of the new U.S. carrier returning to steam catapults is very low, not only because steam technology is outdated, but also because U.S. steam catapult factories have basically stopped production. First, is there really no way to launch the F-35C from the Ford? The U.S. military mentioned a timing issue before. When the Ford began construction, the F-35C was not finalized, so its launch parameters could not be matched in advance. On the surface, this argument seems reasonable, but if you check the timeline, you will find that this argument is untenable. The Ford cut its first steel plate in 2005 and laid its keel in 2009. The F-35C prototype made its first flight in 2010. That is to say, the path of joy and happiness. During the critical construction stage, the top brass of the U.S. Navy were fully aware of the core information of the F-35C's future weight thrust mount structure. It would have been reasonable if they really wanted to adjust the Ford's design, but they did not change their assessment of the adaptation performance of the electromagnetic catapult system.
Failure to adapt suggests overconfidence in electromagnetic compatibility. Ford's issues run deeper. Touted for lower maintenance and higher efficiency, electromagnetic catapults underperform.
It is more precise, but not as good as expected. Fear.
The US isn't incapable of catapulting 5th-Gen fighters. Ford's combat deployments lack full F-35C readiness due to catapult reliability and logistics integration, not inherent system limits.
Let's discuss the technical reliability of the Amplitude system. Tangmush said that in actual Ford-class aircraft carrier deployment, there's also the issue of logistics support. One reason the Ford-class carrier hasn't responded to the F-35C is it needs changes to the logistics maintenance system, including the advanced throttle plate for the F-35 engine in the computer system warehouse. Along with fire protection and ventilation pipeline issues, the U.S. Navy is making these modifications. In theory, this allows future carriers to carry the F-35C. The electromagnetic catapult system problem remains unsolved. As Trump noted, after much searching, the steam catapult is not a reasonable solution. According to Phoenix.com's Ordnance Science and Technology column, the two ejection systems are compared. The biggest advantage of steam catapult is that it is mature. It has been used on many French aircraft carriers for more than 10 years. It is very mature in all aspects. The entire system consists of the launch system, steam system, towing cable tightening system, and buried lubrication and control systems. When they do this, the aircraft carrier's propulsion boiler generates high-pressure steam and stores this high-pressure steam in a gas tank for later use. Before ejection, the carrier-based aircraft is hooked up to the slingshot slider and then opened. And the control valve. The high-pressure steam in the accumulator is released. But inside the steam cylinder, the pressure rises sharply, pushing the piston, which in turn drives the catapult shuttle. The shuttle then pulls the carrier-based aircraft, which slides forward at high speed along the catapult track, launching the aircraft. After the launch, the steam exhaust valve opens, releasing the steam from the cylinder. At the same time, the piston and the aircraft tow bar are decelerated by a water brake and brought to a stop. It is then pulled back to the starting point, ready for the next launch. The maximum energy output for each launch can reach 95 megajoules. It can launch a 36.3-ton carrier-based aircraft at a high speed of 339 kilometers per hour. The entire launch cycle is 45 seconds. On average, each launch consumes about 700 kilograms of steam. The steam catapult has only one moving part, the piston. Launching a carrier-based aircraft is a controlled process. The carrier's speed, wind direction, aircraft takeoff weight, and catapult steam pressure are all set in advance. The key moment for reliability is the first seconds after launch. During this brief time, the chance of piston malfunction is very low. So, for safe aircraft takeoff, a catapult launch is even safer than a land-based one. A U.S. aerospace engineer commented on the Navy's electromagnetic catapult, saying the steam catapult is highly reliable. So far, not a single aircraft has crashed due to a device malfunction in nearly 10 million launches. This indirectly proves the steam catapult's reliability and raises doubts about the electromagnetic catapult. The U.S. electromagnetic catapult uses a linear alternating current system. Its operating principle is that the primary stator of the linear induction motor, when supplied with alternating current, generates a traveling magnetic field. This magnetic field induces a current in the secondary rotor, turning the secondary into a conductor with an induced current. This secondary part, when placed in the traveling magnetic field, is subjected to Ampere's force and moves forward. And the over 100-meter-long winding in the catapult track, when supplied with current, generates an electromagnetic force that drives the armature to move linearly along the track. The armature drives the catapult shuttle, which in turn pulls the aircraft forward. By adjusting the strength of the current, the magnitude of the generated electromagnetic force can be adjusted, thereby controlling the launch force of the electromagnetic catapult. Compared to the complex structure of the steam catapult, the electromagnetic catapult system structure is quite simple. Its weight and size are only about half that of a steam catapult. The energy transfer medium for the electromagnetic catapult is the cable, which uses electricity, while the steam catapult uses high-pressure steam through pipes and valves. The difference in maintainability is clear. The electromagnetic catapult is much easier to maintain. Moreover, it uses a linear electric motor for launching. Braking and resetting only require energizing the system. From a completely cold and shutdown state, it can reach standby in less than 15 minutes. Unlike the steam catapult, which includes many systems and subsystems like hydraulic pumps, steam accumulators, water brakes, and pressure accumulators, and needs to be constantly preheated for the catapult trough during combat readiness. The electromagnetic catapult only needs to remain powered on. The most important thing is that the mechanical wear of steam ejection is serious, especially the metal sealing strip that will be ejected once will cause a certain degree of wear and tear, requiring a large amount of replacement. In terms of work efficiency, the efficiency of the electromagnetic catapult system will be higher, because the steam catapult consumes more than 700 kilograms of high-pressure steam for one ejection, and after each ejection, the steam emitted will also take away a large amount of energy, resulting in its energy conversion efficiency is very low, generally only 4 to 6%, and only nuclear reactors can generate ejection momentum. The steam required for work is difficult for conventional aircraft carriers to maintain high-speed sailing. The bottom is steam ejection gas, which provides high-pressure steam for a long time and uses electromagnetic ejection to supersolve the problems of power generation and damage. The energy conversion efficiency is about 60%, which is relatively high. The demand for energy is greatly reduced. As for the airlift catapult, its energy output is uneven. Electromagnetic ejection not only can accurately control the thrust output, but also causes less impact on the structure of the aircraft during the ejection process. According to calculations, when the average acceleration is the same, the electromagnetic catapult can allow the aircraft to carry 8 to 15% more load than the medium-inflated catapult. This ratio can be used to carry much more ammunition. For customs promotion personnel, they also prefer electromagnetic catapults because they not only reduce the use area of the trouser panel to 1/3 of the original weight and reduce the weight by half, but also do not confuse the final complicated steam pipe puzzle. On the other hand, they no longer cause serious steam leaks and explosions. The maintenance intensity of your clean whitening oil is greatly reduced. Of course, the premise of all this is that the reliability of the electromagnetic catapult in the meantime between failures can reach or even exceed the level of economic catapults. It can be summarized like this.
China's conventional Fujian with medium voltage DC electromagnetic catapults is more reliable than US AC systems, launching J-35 5th-Gen fighters first. Second, US avoids F-35C launches due to Ford's unreliable AC catapults, letting China overtake. Last, electromagnetic catapults are the future superior in efficiency, maintenance, and performance. US. Reversion to steam isn't viable. Its real issue is declining manufacturing and innovation, not technology choice.